In 1.6, we are going to be solving some application problems. Now, these are going to be linear equations that we're going to be solving, or linear functions. But basically, it doesn't matter what kind of equation you use to model your application problem. The steps to solving will always be the same. The first thing you want to do is you want to read your problem carefully and assign a variable to quantities that you need to find. And then with the variable or variables, you're going to write an equation that's going to model your problem. Once you have your equation, you're going to solve. And then once you have your solution, you want to check to see if that solution is a reasonable solution. So this section has a whole variety of application problems, but I'm just going to focus on some of the main types of application problems. The first one we're going to look at is a geometry problem. In example 1, we have the length of a rectangular plot of land is 3 acres less than twice the width. The perimeter is 54 acres. Find the dimensions of the plot of land. So I've read the problem and I know what I need to find. It says at the end that I want to find the dimensions of the plot of land. So there's a length and there's a width. Those are my dimensions since it is rectangular. I'm going to use the generic L, so I'm going to assign my variable. L is going to be the length, and I'm going to have W stand for the width. My goal is to write an equation. When I look back at this problem, I note that the perimeter is 54 acres. And I know the generic formula or equation for a perimeter. The perimeter is 2 times the length plus 2 times the width. So I have an equation that models this problem. The only issue I have with this equation is that there's 3 variables. So in general, if you have one variable, you need at least one equation to solve. If you have 2 variables, you need at least 2 equations to solve. And if you have 3 variables, like I do here, I'm going to need at least 3 equations to solve. But I just want one equation. So I'm going to go back to example 1 and look at what I have. Well, what I have is that the perimeter is 54. So I know I can substitute for P 54. And that will just give me 2 variables, L and W. But I also have that the length is 3 acres less than twice the width. So the length, L, would be my equal. I have a 3 acres less than means to subtract twice the width. So 2 times W. But since this is subtraction, I have to be very careful. Less than means change the order of the subtraction because I'm taking 3 away from 2W. 3 acres less than twice the width. So that would actually be 2W minus 3. So my length is equal to 2W minus 3. Now I can substitute those values into my perimeter equation and solve. The perimeter is 54. That's going to be 2 times in parentheses L, which was 2W minus 3, plus 2W. I have one equation with one variable. I can solve this. On the right-hand side, I can distribute the 2 to get 4W minus 6, and then plus 2W. And then combine the W's to get 6W minus 6. Now I just need to solve for W, so I'm going to add 6 to both sides and get 60 is equal to 6W. I don't know if you can hear the chickens outside, but they're very noisy today. And then dividing both sides by 6, I have 10 is equal to W. So we were supposed to find the dimensions. We were supposed to find the width and the length. I know the length is equal to 2W minus 3. So I have that the length is equal to 2 times 10 minus 3, or the length is equal to 17. If I had gotten 0 or a negative number, that would not have been a reasonable solution. So when I check my solution, it seems like a width of 10 acres and a length of 17 acres is reasonable. But I can also plug that back into my perimeter formula to check to see if 2 times the length, so 2 times 17 plus 2 times the width of 10, to see if that's equal to 54. So I'll have 34 plus 20, which is 54, and this checks out. So that's a good solution. Now I was given the problem in words, so I need to answer in words. So we could say the length is 17 acres and the width is 10 acres, or we can just reword the question with dimensions and say the dimensions are 17 acres by 10 acres. Either way answers the question. So I'm just going to say the dimensions, and you could also add of the rectangular plot, but I'm just going to say the dimensions are, I'm going to directly answer the question, 17 acres by 10 acres, period. Okay, let's try another one. Example 2, again, this is a perimeter problem. Since we're setting up linear equations, we'll often find that these problems will be more of a perimeter problem because perimeter problems are linear equations. So in example 2, we have the perimeter of a triangle is 5 times the length of the shortest side. The length of the longest side is 9 centimeters more than the length of the shortest side. The length of the medium side is 5 centimeters more than the length of the shortest side. So find the length of the sides of the triangle. It's a lot of words, but at the end is what we want to find. We want to find the length of the sides of this triangle. Triangles have 3 sides, so I'm going to maybe use X, Y, Z or A, B, C and define my sides. So I have a shortest side. I'm going to let that be A. B is going to be my medium, and C will be my longest. Notice I'm not really writing complete sentences when I assign my variable. That's just so I know which one stands for which length. But you can be more detailed if you wish. Now I have my variables. I need an equation, and again we have a perimeter. And I know the formula for the perimeter of a triangle. All you're doing is you're adding up the length of all 3 sides, which means my perimeter is going to be A plus B plus C. Again, I have one equation. I need it to be written in terms of just one variable. But I have a lot of information here. I know that the perimeter is, so that would be P would be equal 5 times the length of the shortest side. So that would be 5A. So I have P is equal to 5A. I also have that the length of the longest side, which would be C, is, so equal 9 more than the shortest side. So it's the shortest side was A, and I'm going to be adding 9. And then I have the length of the medium side, which is B, that is equal to 5 more than the shortest side. So that's A plus 5. Now when I look at my perimeter formula, it's going to be 5A for the perimeter is equal to A plus B is A plus 5 plus C is A plus 9. 5A is equal to 1, 2, 3A plus 14. And when I subtract 14 I'm going to subtract 3A from both sides and get the A's by itself to get 2A equal to 14. And then dividing by 2, I have A is equal to 7. So I found A. I still need to find B and C. I know that B is 5 more, so that means B is 12, and C is 9 more, so C is 9 plus 7, which would be 16. All of these answers are positive numbers. I don't get a negative or a 0, so they make sense to me. But I could check them. I could simply add up all the sides and see if it's equal to 5 times A, so that would be 35. Is that equal to 7 plus 12 plus 16? And it is. You get 35 equal to 35. My solution checks out, and I would answer by saying the lengths are 7, the lengths, and you can say the lengths of the sides are, but I'm just going to say the lengths are 7 centimeters, 12 centimeters, and 16 centimeters. Let's now look at mixtures. So that's another major type of application problem. So a mixture of hand sanitizer needs to contain at least 60% alcohol to effectively kill most germs. An 8-ounce container of hand sanitizer is 22% alcohol. How much pure alcohol needs to be added to obtain a mixture of hand sanitizer that is 60% alcohol? So again, we want to find the question in there, and that would be the how much pure alcohol needs to be added. So X is going to be my variable, and I'm going to have that equal to the ounces of pure alcohol, or you could just write pure alcohol. Whenever I do my mixtures, I kind of look at it as containers. I'm starting out with 8 ounces of hand sanitizer that's 22% alcohol. So if I look at this being my mixture, my container, I have 22% and there's 8 ounces. Well, maybe I'll put an OZ in there. That's the mixture I'm starting out with. Now in the problem it says how much pure alcohol needs to be added to this mixture. So I'm going to add a mixture of pure alcohol. Pure alcohol means it's 100% alcohol. But the how much is what I don't know, except for that's my X value, right? It's the amount or the ounces of pure alcohol. So maybe I'll put in parentheses ounces. So I start out with 22% mixture. I'm going to add in 100% of alcohol. And what the result is, so this is going to be equal to, I want a 60% mixture. So I am going to add those together, and I should get a 60% mixture. So the question is, how much ounces of mixture is there? Well, I started with 8 ounces. I'm adding X ounces, so I should end up with X plus 8 ounces. Whenever we're dealing with a mixture problem, we have to multiply the percent of whatever it is, in this case it's alcohol, by the amount we have. So if we look at this first box, it says 22% of my 8 ounces is alcohol, okay? So whenever we have the word of, it's multiply. The equation that I'm going to set up is the 22% times the 8 ounces. So that gives me the ounces of alcohol in the mixture. I'm going to add it to 100% of X would be 100% times X. That should equal to 60% of my X plus 8 ounces. So 60% times X plus 8. I can't solve this equation when it's still written as a percent, so I have to change all my percents to decimals. Just remember, it's just moving your decimal over 2 places to get 0.22 times 8 plus 100% is just 1, so this turns into x, is equal to 0.6 times x plus 8. Remember, that's in parentheses. So just use your calculator. You should get 1.02 plus x is equal to 0.6x plus point. I can't add. Oops, sorry. That was weird. 4.8. I don't have a calculator with me. So usually what I do is decide what side I want my x's on. I notice that 1x is bigger than 0.6x. So I would choose to subtract the 0.6x from both sides. Some people just like to keep the x on the left no matter what. But if I subtract the 0.6x, I get 1.02 plus 0.4x is equal to 4.8. So all I did was subtract the 0.6x from both sides. And then when I subtract the 1.02, because my goal is to get the x by itself, I get 3.04 on the right. So the last thing I'm going to do is divide by 0.4, and I get 7.6. So I got a positive answer. Well, I got not zero, not negative. So positive answer seems reasonable. Now, when I look back here, I see that I started out with 8 ounces. So if I had messed up on my decimal and got maybe 76 ounces, that seems really large compared to the 8 ounces that I started out with. So one thing I want to do is I could put the 7.6 back into my equation and check that algebra, and you'll find that it will work out. But the question is, what if I set up the equation wrong? Then what I sometimes like to do is just look at the quantity. So notice that the goal was to get a 60% solution. If I look at 22%, that's 38% away from 60. If I look at 100%, that's 40% away from 60. So if you look at the difference between the 22 and the 60 and the 100 and the 60, they're roughly the same. One is 38, one's 40. They're very close together, which means that when I find the amount of ounces for each one, they should be similar. So 7.6 is very close to the 8 ounces of the 22%. So that 7.6 makes sense to me. And then my sentence, normally we don't, like you could say 7.6 ounces of pure alcohol must be added. But normally we don't start with a number unless we're going to spell out the number. So the trick here is just to add thus or therefore. I'm going to use thus because it's shorter. Thus, 7.6 ounces, and I'm just going to do OZ of pure alcohol. Let's see, must be added. Again, you can word it any way you choose as long as you answer the question. So let's do another mixture problem. In example 4, a chemist needs 20% acid solution for an experiment. He has 3 liters of a 34% solution. How many liters of a 10% solution needs to be added to dilute the 34% acid solution to a 20% solution? A lot of words. Question is, how many liters of a 10% solution? So that's my x. X is going to be the 10% acid solution. So if you want to add acid to remind yourself that it's an acid solution, that's fine. So if x is the 10% of the solution, then let's see, we need a 20%. Oh, he has 3 liters of a 34% solution. So that's what we're starting out with. We're starting out with this 34% solution. and we have 3 liters. We're going to add the 10% solution, so very similar to our last one, just different words, and that's X liters. Once we do that, that will be equal to the 20% acid solution that we're looking for, right? And similar to the previous one, the amount of liters would be X plus 3. So again, we start out with this 34% solution. We're going to add in some 10%, and then we should end up with the 20% solution. Our equation, remember we're going to switch our percentage to decimals, would be 0.34 times 3 plus 10% would be the 0.1 times x is equal to 20%, which would be a 0.2 times x plus 3. Again, you could just use your calculator to figure out those values. We should get a 1.02 plus 0.1x equal to 0.2x plus 0.6. Now this time I think I'm going to put my x's on the right hand side because I noticed that the 0.1x is smaller than the 0.2x. If I subtract 0.1x from both sides, I have 1.02 is equal to 0.1x plus 0.6. And if I subtract 0.6 from both sides, I should have 0.42 is equal to 0.1x. And then divide both sides by 0.1 would give me a 4.2. It's a positive answer, so that is reasonable. And I started out with 3 liters, so adding 4.2 liters is a reasonable answer. Now I could simply put the 4.2 back into my equation to see if it works. But then again, if I set up the equation incorrectly, then I would get the 4.2 would be incorrect. So my other check is to say, is 4.2 really reasonable? Yes, because it's close to 3. So my sentence that I'm going to have is going to start out with a thus, comma, well, it looks like this, thus, 4.2 liters must be added, or I can get more specific, 4.2 liters of the 10% acid solution must be added. And that would be it for our mixture problem. The last type of problem I would like to set up is a variation problem, in particular a direct variation. There are a bunch of different variation problems. In this section, they're only covering direct variation, which is the simplest type of variation problem. And when we talk about direct variation, it's just a proportion where we are comparing two quantities. So a number y varies directly with x if we can find some non-zero number k. So k here is called our constant of variation, such that this equation is true. Y is equal to k times x. When you're solving a direct variation problem, in the words you may see varies directly or directly proportional. If you see those phrases or words, then that tells you it's a direct variation problem, and the equation that you would use is y equal to kx. In example 5, it says if y varies directly with x and y is equal to 10 when x is equal to 3, find y when x is equal to 18. So the variables are already given. I know that I have to find y when x is 18, but if you look at this first part here, we have that y is equal to 10 when x is equal to 3. I know it's a direct variation because it says varies directly. So I know that I'm going to be looking at y equal to kx as my equation. And the first part says when x is 3, y is 10. So I can simply take this equation and solve for my constant of variation k by plugging in 10 for y and 3 for x. So dividing both sides by 3, I have this constant of variation 10 over 3. Now the constant of variation never changes. So your x and your y values can vary, but the k cannot. It's constant. So now my equation is y equal to 10 over 3 times x. Once I solve for that constant of variation, I can find y when x is equal to 18 by simply plugging in 18 for x to get y equal to 10 over 3 times 18. So y is going to be equal to 60. That's how you solve a direct variation problem in two parts, where you first solve for k, plug that into y equal to kx, and then you solve for your, in this case, y value. Or going back to this language, directly proportional. A direct variation is a proportion. So a proportion is when you can just set two fractions equal to each other. So the other way that we can solve this, instead of actually finding that constant k, is to look at what we're comparing. Here we're comparing x and y. So I can either set it up as x over y, and in the first part I know that when x is 3, y is 10, so that should be equal to when x is 18, solve for y. And then I have a proportion that I would maybe do cross multiplication and solve for y. But also when you have a proportion, you can choose the order that you set up your fraction. I notice that my y that I'm trying to find is in the denominator, so maybe I want to put y's over x's, which is perfectly fine. So I'm going to have y is 10, x is 3, is equal to y over x is 18. And that might be easier because all you have to do is multiply both sides of this equation by 18 to get y is equal to 60. That's up to you if you want to set up a proportion or if you want to set up a direct variation and solve for k first. So the reason is, if it's just as easy to set up a proportion, why do we do y equal to kx? Well, the direct variation is just one type of variation problem. Later on in this textbook, we will see more complicated variations like inverse, joint variation, combination variation. And in those cases, it is sometimes easier to use the k equation, the variation equation that's given to you, rather than try to set up a complicated proportion. But again, feel free to use proportion or variation. Sometimes you'll be given problems in the textbook where they don't tell you it's a direct variation, but if you're still comparing quantities and you're given the first set of quantities and then you have to find some value. So for example, Hooke's law. Hooke's law is a common direct variation problem from physics. So Hooke's law is actually comparing how a spring stretches to the weight that's attached to it. So if you have a spring and you attach a weight, you have some spring, and you attach a weight to the bottom of it, how far will that string stretch? That's a sad looking spring, depending on the weight that you attach to it. So you're comparing the weight in pounds in this particular case with the how a spring stretches in inches. So we're comparing pounds to inches. And we're told that if a 4-pound weight stretches a spring 3.4 inches, how far will an 18-pound weight stretch the spring? So we're comparing these quantities, and we're given the relationship in the beginning that a 4-pound weight stretches a spring 3.4 inches. So we can use that to solve for k if we were to set up a y equal to kx, where my x could be the weight that I'm attaching to figure out how far my spring y stretches. And in the beginning, I know that if x is 4, y is 3.4. I can use that to solve for k by just dividing both sides by 4. And I'm going to put that in my calculator to get 0.85. And now I have y equal to 0.85 times x. I can answer the question. If x is 18, right, that's the weight, what is y? So I'm just going to multiply by 18. Again, in my calculator, I will get 15.3. And now this particular question had units and words and all that stuff. So the spring will stretch 15.3 inches. That's a 15. Okay. So how would you do this if it was a proportion? Well, I'm trying to find how far the spring will stretch in inches. So I want the inches to actually go on top. I'm going to set it up as inches over the weight was in pounds. And I'm told that 3.4 inches goes with a 4-pound weight. I'm trying to find my inches when I put in 18 pounds. So that would be the proportion. Again, I would just simply multiply both sides by 18 to get the solution of 15.3 in a calculator, right? So again, either way. The very last thing we're going to talk about is formulas, solving formulas. So sometimes when you're working with formulas, maybe you don't want it to be, like in this particular case, in example 7, I have A equal to 1/2 H, and then I have a big B plus little b. So if you don't know that formula, that's the area of a trapezoid. So maybe I don't want to find the area. Maybe I want to solve this formula, say for H. So maybe I'm going to put in different areas and different, so B stands for the longer base, little b stands for the smaller base. Maybe I'm going to put in different areas and bases and try to get a height, see how the height changes. So oftentimes we want to solve a formula for a specific variable. So get that variable by itself on one side of the equal sign. That's real common when we have relationships like maybe Celsius and Fahrenheit. So in this particular case, we have to follow our order of operations. If I'm solving this area formula for H, what I notice on the right-hand side is this is all multiplication. So I have 1/2 times H times, in parentheses, big B plus little b. So I have a choice. I can multiply both sides by 2. So again, the goal is to get the H by itself. I can multiply both sides by 2 to get rid of the 1/2 on the right. And then the 1/2s cancel because that's just 1 times H. To get 2A equal to H times, in parentheses, big B plus little b. And then to get the H by itself, I would simply divide both sides by big B plus little b. Remember, that is, because of the addition, that's one piece. So I can see that the B plus B's, those would cancel. And I have that H is equal to 2a, over big B plus little b. And that's it. Just a few applications and then solving for a formula.